Hello, my name is Suliman Sattar, student at King's College London, and today we focus on public assistive displays, looking at the for all display. Our aim was to look at how passenger displays can be used to assist passengers on public transport with individual needs. To do this, a three-step process was enacted by first investigating the need public transport users have, understanding these barriers the users face, and then thinking about how public displays could be used to dismantle these barriers. TfL reports that 1.35 billion passenger journeys are completed annually. However, research has continued to identify that public transport is regularly inaccessible for many communities. For pregnant persons, TfL provides a badge that can be worn, and hidden disability lanyards can be worn for those with invisible conditions, where both these methods put the focus onto the person carrying stigma and often being overlooked or made to feel that they need to prove their condition. Certain seats are also marked as priority seats, but are often occupied by passengers without access and needs, again leaving the onus on the person with a need. Using insights gathered from the interviews and focus group, we prototyped a PID called the for all display. On the hardware side, the graphical software was connected to a station Arduino wired to an RFID sensor. RFID tags are used which contain simple instruction sets such as allergy and coffee. For the software, the graphical user interface was a Python application that reads and displays the information from the RFID tags. As shown here, when a user boards a carriage, they would tap their badge on the RFID sensor, which then triggers a customizable display message. A range of messages can be displayed, such as pointing to specific allergies, making passengers aware of people requiring assistance, or general reminders to be more considerate of other people's needs. Most messages are framed as instructions to guide users to the appropriate reaction once they notice display, allowing them to quickly accommodate. To test the for all display, a lab environment was used with projection seats to simulate a tube carriage. In approximately 1.5 hours, 90 scenarios were tested to see the reaction of participants, each approximately lasting 2 to 3 minutes. Following the scenarios, participants gave an exit interview. Overall, there's an 84% success rate. Success was defined as participants changing their behaviour appropriately based on the output of the display. The average participant time to change behaviour was 9 seconds, however this would be influenced by familiarity. On 3 occasions, for all display was unsuccessful as participants misunderstood its message, therefore not reacting in the desired manner. Qualitatively, all participants were not comfortable with the for all display being present and see being used in the real environment. Some improvements were mentioned, such as using standard symbols of the public transport network, in this case TfL, to avoid confusion. Participants also thought about integration improvements, such as simultaneously having voice announcements. However, there was some unsurety around how to most appropriately act to accommodate co-located needs. We recognise there are a number of limitations with the research. By using a lab environment, we get to the many complexities of live transport systems, such as a moving carriage environment, constant influence of passengers, and sudden loud noises. Especially sample size makes generalisation difficult. To remember this, short to medium term field deployment of display in a real-world setting will provide more established findings. Research also paves the way for future work with further study required around integration into the infrastructure due to reliance on proprietary equipment. Currently, the display does not feature an exit state and continues to show the last end user need, posing another question around how multiple passengers with needs will be accommodated. Research, however, shows that it can be adapted for a range of communities, and from further investigations, new communities and adaptations can be solved. Thank you.